Hi everybody, here's Ned Coke for MIS5390. This is the first video of the fifth week of the course. Let me just tell you that on the commentaries, I don't have any commentary. All the commentaries meet the requirements. So I don't have any commentary that needs to be redone. Let me choose the best commentary. So several commentaries were very good. I would choose this one by Gabriel because it gave me some extra insights from on the project, and it was very descriptive, to the point. So good job, Gabriel. Now let me tell you that I looked at the first project that was submitted. I received both projects. Srinivasulu's project and also Angela was sent via message. I got it. Thank you. Both. I received both of them. And let me show you what I got. So I actually started looking at Srinivasulu's team's project, and here's what I got. Okay, so very different from the results that you got there before. And I'll show you in a little bit how I got to these results. But the results that I got here, as you can see now, all the variables are measured through single indicators. Let me show the indicators that I used, the columns in the data set that I used. So distract, I use distract, suspension, I use suspension, intense, I use intense, absence, I use unexcused absence rate. This one I created through a machine learning algorithm that would be AI, logistic regression variable. So that really increased the R squared, the percentage of variance explained in this main dependent variable or main criterion variable progress. So it's 60% explained. So this is very good. I controlled for year, and I'll show you how to do that, and I controlled for gender. So these two links here, they just mean that I'm controlling for gender and controlling for year, because your data set is a panel data set. You collected data from the same student at multiple years. And because of that, I had to control for the impact of year on the analysis, right, with respect to the main dependent variable. So what these results are telling me is that more distract leads to more progress, more suspensions. So this is, more suspension. More suspension leads to less progress. Well, it's negative, minus 0.36. More absence, less progress. So more suspension, less progress. More absence, less progress. These two are to be expected. More distraction being associated with more progress. That's the odd one, right? And I would argue that there is an explanation for this, and it could be that those students that are the most distracted are the brightest, and because of that you see more progress with them. But there can be other interpretations. One of them is that more distracted students tend to attract more attention from the teachers, and because of that they have more progress. So they are treated differently to reduce distraction, and that leads to more progress, even though the declared distraction is positively associated with progress. This can be an explanation for that, or just being more distracted is associated with being brighter, and that leads to more progress. It really depends on how the data was collected. So let me tell you what I did with the data set here. So here's the original data set you shared with me. And what I did was to separate this into numeric data that can be used. And I created two categorical data variables here, school ID and year. This one was needed for the control. And the others I didn't use. Student ID, even though is numeric, it doesn't mean anything from a numeric perspective, right? So if student 5 is not more than student 1, it's just an identifier. Same thing with student ID. So for all purposes, these two are categorical variables. So they're labels. They don't mean anything from a numeric perspective. Now, since you collected data from the same student in multiple years, so you see student 1, you collected data in 2022, 2023, and 2024. Because of that, I need to control for the effect of collecting data in 1 year on the results of your analysis. So that's something I had to do. You have to do this when you have panel data like this. And you do have to create a categorical variable for year, because if you leave year as a numeric variable, you're just trying to control for the passage of time, and that is not appropriate, because it could be that one of the years had a particular nature associated with that year that influenced the results more than the others. So just controlling for the passage of time is not appropriate. You have to categorize the year variable and then do a numeric, a categorical to numeric conversion in the software, and then include year as a control variable. Now, one of the reasons I did all of this is because I wanted your team to meet that requirement that I set for an A-level project, which is to have 7 variables or more. And as it turns out, we have 7 latent variables or more. So we have 1, 2, 3, 4, 5, 6, 7. The other 2 are control variables. And I put them on the side here because they're control variables. That simply means to me that they're control variables. I'm not interested in these results. I'm just interested in these other results, controlling for these 2 variables. So it means that these other results hold regardless of year of data collection and gender. Now, gender, I left coded as originally was 0 and 1 because there's 2 genders here. As far as I can tell, it's just 2 genders. Yeah, just 2 genders, 0 and 1. So my guess is one is female, the other is male. So it's actually not gender what you're measuring here, according to social scientists. This is more like biological sex. But I can leave the numbers because it's just 2. So when I have just only 2 categories, I can dummy code them as 0 and 1, and that does the job. Now, if I had like 3 genders, then I would have to do the categorical to numeric conversion to control for gender. So, okay, so I got these variables here. By the way, the other results, like this one here, this one, and this one, I consider them to be 0 because of effect sizes. So even though this one is significant, see the p-value is lower than 0.05, I consider it to be actually zero based on effect size. The reason why it's such a small effect, right? The reason why it's significant is because of the large sample size that you have. With very large sample sizes, anything becomes significant. But if you go and look at the effect sizes here, you will see that the threshold here for effect sizes is 0.02. Anything lower than 0.02 is too small to be considered a real effect. And as you can see, it's only those three variables that I mentioned that have effect sizes that are above that threshold, 0.02. This is in the user manual, by the way. So it's just these three that are significant, and also with effect sizes that are high enough to be considered real effects. Not even this one is. So this one I would consider to be zero. Okay. So no impact of intensity on distraction, suspensions, progress, and absence. So one of the findings of your study is that the intensity of the policy has no impact on anything, not on any of the variables that are here in the model, which is a finding in and of itself. This could mean that how it was implemented was not very effective. But you have impacts of distraction, suspension, and absence on progress. And these are the important ones. These two, from absence and suspension on progress, seem to be common sense. This one is the interesting one, right? So there is a story here. There is something going on here. And also, again, one of the findings of your analysis is that intensity has no impact on anything. Now, let me show you how I got to this and why I did that. So first, let me make sure I save this. So let me open the file you sent me. So let me check this is the one you sent me. So one of the reasons I didn't like this is that based on this project, based on this model, your project does not meet the requirement of having 7 latent variables or more to be an A-level project. But there is another problem. When I looked at the aggregations that you did here, I noticed something that is problematic, which is that when you looked at loadings, you see that for intense, the 3 indicators that you decided to aggregate, they are not actually of the same sign. There is one that is negative, the other 2 are positive. So perhaps you could aggregate the other 2, but not this one with the other 2. It's just aggregation here messes up the results and make the results nonsensical. And the other problematic one is that when you have 2 only, they get the same value for loadings, and it essentially means that the software just finds weights here that are the same, and it doesn't allow you to make this type of comparison and see if they really mean the same thing, right? And when you look at the correlations between these 2 indicators, they are not high enough for you to really trust that they measure the same thing. So the aggregations here don't really work, and in fact there is the findings here are a little odd too, but then again, they're so small that you would have to consider them to be zero based on effect sizes. So let's go back to the model that I created and that I will share back with you. That's this one here. I tried another one, but I didn't like that one very much. So let me tell you how I got these results. So the first thing that I did was to have the variables themselves from the data set. And then what happened, so let me just show you what the results that I got before with the original variables. So I'll just change this one. This is a logistic regression that I created, logistic regression variable. Let me use the original one so you see the results. So if I save the model and reanalyze the data, and here the settings I set as linear and robust path analysis because I have only one indicator per latent variable. So this is the most computationally efficient. So then when I redo the analysis, one thing I didn't like was that this R squared is too low, and it tells me things that I don't like. It's so low that it's explaining only 4% of the variance, which essentially means that the analysis is it doesn't account for much. And sometimes this happens because the amount of variation in this dependent variable here, progress, is too small. So converting this variable to a logistic regression variable changes it, and I will show you how to do that. So you go to Explore, Logistic Regression, and then Logistic Regression Logit, and then you choose progress, and then you choose the indicators. You choose the predictors, which are these three, and this one, according to my analysis. So it's distract, suspend, suspensions, absence, and intensity. So this one, this one, this one, and the other one, distract, absence, suspension. Oh yeah, distract. That's the one that's missing. So when I add them, then I get the results that I showed you before. So what I did was I then chose the option here at the bottom, create logistic regression variable. I clicked on the yes, and then it created to me, which was added to the data set as a new indicator. It created this variable here, L progress. And the difference between progress and and logistic regression progress is that this new variable measures the probability that progress is above average in the data set. Okay, so that's a probability that I generated. It's a probability variable that I generated. So then what I did was to go to my model and change the indicator here from the original progress to logistic regression progress. And then I saved. model, and then I redid the analysis, and that's where I got the results. Now for year, what I did was this. I went to the data set, and then because with categorical variables, you have to select them one at a time. So I selected the year variable categorical. I then copied this into the clipboard. Then I went to the project file, and then I went to modify, add data labels from clipboard, and then clicked OK, and then I just followed the wizard, but then that's what allowed me to read that label variable. So I read that year categorical variable into my analysis, and then what I did was I went to explore categorical to numeric categorical conversion. I chose categorical to numeric. I chose year, and then I chose intensity, because intensity in my analysis is the main independent variable in the analysis. So that's the one I'm controlling for with here. So I don't want year anchored on intensity to influence the results. If it influences the results, I would control for that influence. But then I clicked on yes, and then I got this variable here. Let me show and hide the indicators. Sorry about that. So then I created this C2N year. And so this is a numeric variable that the software created for me so that I could control for the year of data collection. And as you can see, the impact is non-significant, but it doesn't matter. It's just a control variable. So I can say that the results hold regardless of year. So this is it. The group, good job. You have a project that is A level. I will share this project file and also that modified data set with you under module 5. And now, if you agree with these results, that they make sense, what I suggest you do is start preparing to write your report on this. But this is an A-level project because the project is complex enough for an entire team project for the capstone course, right? The problem with doing too simple. So these examples that I shared with you, they were actually used in a previous course, but they are simplified examples to show what types of analysis can be done, and they were individual assignments. So for a capstone team project, you need something more complex, and this is why I was asking for 7 latent variables. And since I told you you can use single indicators for the variables, that's what I did here. So you meet the A-level project requirement. So you're good to go. Now it's writing the research report. It should not be a problem for you to write that research report. You don't have to worry about reporting validity and reliability results, but you should report something that I have here, which is these full collinearity variance inflation factors. As you can see, they are lower than 3.3, which means that you have no collinearity in this model, which essentially means that all of these variables, including the control variables, measure different things, which is important in an analysis of this type. So this is all I had for today. I will talk about the other team's projects in the next video that I will prepare this week. And don't forget, there is the individual assignment commentary at the end of the week individually by everybody. So thank you for watching.